We look up at the night sky and see a frontier waiting to be explored. But the reality is, the human body is a hyper-specialized machine, evolved over millions of years to function in exactly one highly specific planetary environment. Step outside that environment, and our survival depends entirely on wearing heavy machinery. A spacesuit is essentially a wearable, armored bubble of Earth. If that bubble pops, the clock runs out instantly. Forget the cinematic quiet of a spacewalk. We need to look closely at what the violent physics of our solar system actually do to human biology. Stepping onto another planet means subjecting your anatomy to highly specific, highly efficient mechanisms of execution. Take Venus. Its atmosphere is so dense that the surface pressure is 92 times greater than what you feel sitting in your chair right now. If you landed there, that atmospheric weight would collapse a standard spacesuit in about a millisecond. In the exact same moment, the 465 degrees Celsius heat generated by a runaway greenhouse effect would begin boiling your internal organs. Mars presents the opposite problem. Instead of a crushing weight, the atmospheric pressure is almost completely absent, sitting at barely 0.6% of Earth's. Looking at this blood vessel under rapid decompression, we see a lethal biological chain reaction. Without external atmospheric pressure pushing against your body, gases dissolved in your blood rapidly expand and boil your fluids from the inside out, a condition known as ebullism. Even if your suit manages to hold its pressure, Mars will test your equipment relentlessly. The planet is covered in massive dust storms made of ultra-fine particles that easily infiltrate and destroy the delicate mechanics of your life support system. If we move out to the gas giants, the physics change entirely. On Jupiter, there is no solid surface to crash onto. Instead, you face an endless free fall through massive electrical storms, dropping deeper into an abyss until the mounting pressure finally breaks your capsule. Whether an atmosphere is overwhelmingly heavy, almost non-existent, or endlessly deep, having the wrong pressure rips apart the delicate balance of the human body. Pressure is only one mechanism of off-world destruction. On a planet like Saturn, the primary threat is sheer velocity. The rings of Saturn are a massive, chaotic debris field of billions of icy rocks, orbiting at 70,000 kilometers per hour. This creates a lethal environment for silver ships attempting to navigate the scale of the kinetic rocks. Then there is Neptune. It holds the record for the most violent weather, with atmospheric gusts tearing across the planet at 2,100 kilometers per hour. This schematic shows a spacecraft caught in a Neptunian vortex. Supersonic winds spin the ship, generating extreme outward centrifugal force. Accelerating to 10 Gs, that force drives blood away from your brain and aggressively pulls it in your legs, causing fatal oxygen deprivation. In the outer solar system, planetary velocity operates as a raw, destructive force, generating enough kinetic energy to shred metal and pool human blood in the lower extremities. Closer to the Sun, threats become microscopic. On the day side of Mercury, a lack of atmosphere means your body takes the full impact of unshielded solar radiation, which immediately begins mutating and destroying your cellular DNA. Conversely, if you land on Mercury's dark side or travel all the way out to a dwarf planet like Pluto, the temperature plummets to negative 239 degrees Celsius. Under extreme thermal shock, frostbite sets in within 30 seconds. Minutes later, your fluids freeze solid and your internal organs shut down. But perhaps the strangest death awaits you on Uranus. The atmosphere here contains about 2% methane, meaning a single microscopic breach in your suit will poison you almost immediately. If your body were to sink 10,000 kilometers beneath those toxic clouds, you would hit a zone of unimaginable heat and pressure. We see how extreme conditions inside the ice giant interact with human chemistry. 18% of your body is carbon. At those depths, the crushing weight squeezes the carbon atoms in your remains, snapping them into a rigid lattice, literally crystallizing them into diamonds. Extreme conditions at the edge of our solar system actively dismantle your biology, crushing your cells until your basic chemical makeup is entirely overwritten. Boiling blood, supersonic centrifuges, crystallized cells. The survival rate for an unprotected human anywhere else in the solar system is exactly 0, and that highlights the incredible rarity of where we are right now. Earth provides a perfectly tuned magnetic field deflecting radiation and a precise balance of atmospheric pressure holding our biology together. Space colonization relies on the successful engineering of perfect microscopic simulations of Earth's exact conditions, armored bubbles capable of withstanding the surrounding violence. Every step off our home planet remains a desperate technical battle to survive the absolute intolerance of the vacuum.